between the load and deformation and the failure property. Sometimes for brittle materials, if the member is made of brittle materials, the failure is correct, it's break. For ductile materials, the failure is large deformation. They are different. The property of materials is inherent to the material. If we want to get the property of materials, we have to do tests. We do experiment. At first, we have to get a test specimen. How to get the test specimen? Different countries have different code. In China, if we want to get the property of material, always the length is 5/10 the radius. Okay, it's diameter. Yes or no? In China, L is 10 diameter or 5 diameter. In Chinese code, but different countries have different code. Here is the code is not China because the property depends on the size of the material of the member. If the size is very large or very small, the property are different. The property almost depends on the circumstance. The temperature and other things, and the speed of the load. Sometimes we add the load very quickly. Sometimes it's slowly. We will get a different property. So we have get a code how to do the experiment. Is the test machine? Is the machine put the test specimen on the machine, then add the load, put the load on the specimen. Is the gauge to get the deformation of the specimen. We put it on the surface of the specimen. Then we can do the experiment. After we do the experiment, we can get the graph. We can get the graph. In this lecture, the purpose is to know the conception. This conception, how to describe the property of the material. At first, when the rod is loading, when the loading gradually go up, the deformation will gradually go up. It's the root of the deformation. The curve divided into 4 sections. The first section is a straight line. The first part is a
কি বলে মা
straight
কি বলে নিজেও জানে না
It means the stress is proportion to the strain. Proportion is proportion to the strain. So is a straight line. After the stress, pause a special point, the straight line become a curve. We call this point, we call this stress is proportional limit. It means when the stress is less than proportion limit, the stress, the line is a straight line. After the stress more than the proportion limit, the curve, the line become a curve. After the stress go up, then this point, when after we remove all the load, the member can't back its original length. It means there is it means the member is yard. So if the stress is less than this value, we call it an elastic limiter. We call it elastic limiter. After we remove all the load, all the deformation will disappear. So we call it an elastic limiter. In practice, almost most of the member, when they are working, the stress must be less than elastic limiter. If the stress is more than elastic limiter, we call the member is failure. So after the stress is more than yield stress, after the stress is more than elastic limiter, the deformation will go up very large, but the stress don't go up. It means the line is almost horizontal. The stress don't go up, but the strain become very large. We call it yard. Actually, we can't allow this yard when it is working, because it's large deformation. Yeah. In the beam there is steel rod. Most of the steel rod is on the bottom part, in the mid section. For the beam, most of the steel rod will arrange it on the bottom part of the beam and in the mid part of the beam. because in this location, in this region, the materials is in tension. But the stir, we can't permit this stress in the stir more than elastic limit. It must be this stress in the stir must be less than elastic limit. Can't go to yield stress. If this stress in the stir come to yield stress, the deformation of the stir must be very large. The beam will bend. We can't allow it. Elastic limit is the property of the material. We get it from experiment. From the test is a experiment. At first, we have to make a test specimen. Yes or no? Because different cells have different property. So we have to get a code. According to the code, make a specimen. Because the property depends on the size. Then put the specimen on the machine. After you put it on the machine, then load it. We can get the deformation and the stress. And this gauge gets the deformation of the specimen. We put it on the surface of the specimen. This gauge may deform with the specimen. When it is deformed, we can know the strain in the specimen, and that in the future you will know how to put it on the surface. Use glue. Put it on the specimen. Elastic limiter. So we call this stress is yield stress. After this stress is more than yield stress, the line go up. We call it hardening phase. Hardening section. It means when the loading go up, or when the strain go up, the loading also go up. In this section, the deformation go up, but the stress don't go up. Why? Because the material is yield. It means when you hit someone, he can't hit you. He just take it. He just accept it. Yes or no? So it means yield. At first, at first you hit you. Yes, no. So it's getting is you felt is getting is yes, yes. After aware, one of you scared. Yes, one of you afraid it. Yes, no. It's yet. It's yet. But when he fell, his life is danger. So he have to hit you again. Yes, no. But what point? One of you will go to die. Go die. Yes, no. It means fracture. It means fracture. Sin is sin to the left. Yes, no. It's sin. So it's ultimate stress. It's ultimate stress. After the stress, after the curve, pass ultimate stress. The stress go down. Why? Because likening appear happen. That's happen. Then fracture. So fracture, yes, is fracture stress, yeah, yeah. To it means after the curve come to this point, some of the location of the specimen contraction. It means lacking from lamina is a pair. Two factor stress is the load divided by the two area. Understand? Because the area is less than its original area. Yes, sir? So two fracture stress is the fracture loading divided by the two area. We call it engineering fracture stress. We get it from it's the fracture loading divided by its original area. So it's go down. It's the true fracture stress is an engineering fracture stress. It's different. We call this part is elastic behavior. This part is plastic behavior. Same. It's same. This figure is same. Is the same. This figure. In this figure, where I will introduce unloading. In the holding section, is the holding section is when you gradually decrease the loading, the relationship of the stress and the strain will go down along this straight line. When all these loading are removed, there is deformation. There is strain. When all the loading are removed, there is loading. There is load on the member. But the deformation doesn't disappear. Yes, now we call this kind of deformation is plastic strain. But because at this point, actually, the strain is Hg. So this part, when this loading is go down, this part is disappear. It's not is disappear. This kind of deformation, when the load is removed, the deformation also disappear. This kind of deformation, we call it elastic strain. So the strain, there are two parts. One is the plastic strain. The other part is elastic strain. One of them. We don't allow this stress more than elastic strain. Actually, in practice engineer, we don't allow this stress more than elastic limiter. It means all the deformation will be disappear when the load removed. After all the load is removed, then we can reload it. Yes, when we reloading it, the relationship of this strain and the stress will along this line. In this time, the elastic limiter is here. It's at first the elastic is here. It's more than the previous one. Yes or not? So we call it hardening. We call it hardening. It means when this, suppose the material is steel. Suppose the material is steel. Yes or not? We can't allow the stress more than elastic limiter. In this case, when we make this beam, suppose we have to use 3 rods or 4 rods, but after we exert load on the rod, then it will be hardened. The elastic limiter increased. Yes or not? So perhaps we can serve 1 rod. It means maybe we just use 3 rods is enough. You know, the load Fm equal sigma A, do you know? It's water. We know the load is Fn equal sigma A, do you know? We know it, yes or not? Suppose we know it, it's the law, it's the formula, we know it. the maximum lobe loading Fn is sigma elastic EA. Yes or no? Because the stress must be less than the elastic limit. So the maximum internal normal force is we can get it from the formula. If the elastic limitation increased, because at here the elastic limit is more than the previous case. Yes, so because it is go up, it can go down. Yes, the area can go down. It means we can use less material to build the same beam. Understand? So actually, if we want to save money, when the steel come to the build the projection, at first we elongate the steel. Elongate steel. It means we try to increase the elastic limit of the steel. After we increase it, the elastic limit go up. In this way, we can save steel. Answer that. Hawkes law. Last lecture I introduced the Hawkes law. The Hawkes law comes from experiment. It means in the first part, because it's a straight line, the slope of the line is the from this line we know sigma equal d theta. It's not because it's a straight line, so we call it Hawkes law. E is a constant. This is a great material. When we do experiment for this kind of figure, is dog-tail material, because dog-tail material have 4 parts, so it's convenient to introduce the conception to describe the property of material. So we explain it in details. But for brittle material, for brittle material, the deformation, it means the strain is small, but the stress go up very quickly. The deformation just have one part. Then rupture is brittle material. sometimes there are plastic brittle material, ductile material. How to get the yield strength? It means when this strain is the normal strain, when the normal strain comes to 0.2%, we do a straight line is parallel to the first part line. This loop, this we call it this we call the stress at this point is yield strength. Is also yield limit. Doctor, if there is no clear transaction point, it means there is no clear yield section. There is no horizontal section. Yes or no? So we call this stress is yield stress. Different material have different property. So there is a lot of important knowledge. We just in this subject, we just need to know. We just need to know this conception in this figure. We ignore all the other conception because we have a subject. It means engineering material. If your major is civil engineer, there is a subject. It means it is civil engineering material. In that subject, all this conception will introduce again. It's more the knowledge will more clear than in mechanics material. So we just need this kind of thing is enough. Fatigue. We just need to know there is this kind of formula, fatigue. It means suppose is a steel, but if you want to break it, intention is very, very difficult. I suppose all of you can do it. For very small steel rod, all of you can break it intention. But if you just want to break it, you can test it many times. It will break. It means fatigue. It means when the load is put on and put on remove many times, the friction, the break property is different. This formula we call it fatigue. We just need to know this formula. in this subject. We didn't know it in detail. If you focus on this formula, you will be a specialist. It's not way purpose. Poisson ratio. Poisson ratio. When a rod is in tension, the length will be longer. Yes or not? The length will be longer. We can get a string. We can get a string in its longitudinal direction. Yes, is in this direction we can get a longitudinal string. In the same time, the diameter will contraction. Yes or not? Will be less. Will come down. In this direction, we can also get a string. The ratio is the ratio of these two strings. We call it Poisson ratio. Yeah, it's a constant. It's a constant. This figure it means when the rod is in compression. Yes, not. In this case, the axial direction, in axial direction, the normal string is negative. But in this direction, this string is positive. In this case, is opposite. Yes, but the ratio is the ratio must be negative for the two cases. Because one is positive, the other one must be negative. Poisson ratio is the absolute value of the ratio. So it's always positive. Yeah. So we plus a negative sign before it, so it will be always positive. Is constant is the property of the material. It means in the future we will know when the view it's half. The value of the material don't change. Even a lot of force act on it, the volume of the material don't change. When the Poisson ratio is half, we will know it. We know Hawkes' law. Yes or no? Is Hawkes' law. Yes or no? I introduced it. It's also Hawkes' law. Yes or no? Can you remember it? It's also Hawkes' law. It's shear stress, shear strain. The relationship is also proportion to shear strain. But after I introduce the Poisson ratio, we can introduce generalized Hawkes' law. It means we know. Suppose the bulk is loaded in 3 directions. They are perpendicular each other. When this one acts on it, when this one sigma z act on it. So in the z direction, in the z direction, sigma is if set z will be sigma z over e. Yes. Suppose just one of this load act on it in z direction. There is a string, is not? According to Hawkins law, we can get it. At the same time, because of Poisson ratio, yes or not? When the Poisson ratio V is V, we can know it from the formula. So we can get a sigma epsilon x. We can get an epsilon x because suppose just the one load act on it, this will remove this two load, just one of them act on it. In this direction, we can get a string. But in the same time, in x direction and y direction, there will happen. There will string. Yes or no? It's yes or no? Because epsilon z over epsilon x, epsilon z is minus gamma. Yes or no? So epsilon y will yes or no? Just one load, just sigma z on it 0, 0, 3 string. In the same way, we know there is 3 load. Yes or no? There is 3 load. Then sigma z, and then sigma x, epsilon x, sigma x, e, that is sigma z, epsilon y. Yes or no? Then we can make a summation of the same direction. So epsilon z, yes or no? Epsilon z in the direction. Because of sigma z, there is a string. Because of sigma x in the direction, there is a string. Because of sigma y in the direction, there is a string. That's that. So we call this relation is generalized Hawkins law. That's that. Same. There is share Hawkins law. We got it from experiment. This curve, we got it from experiment. Tau proportional limiter. When the stress is less than tau proportional limiter, the curve is a straight line in this part. So it means tau is proportional to gamma. Gamma is share string. We introduced the Poisson ratio, E models of elasticity and the models and the share models of elasticity. Yes, now we introduce 3 constant for a given material, but there is a relation between among this constant. In the future, we will prove it. But today we just accept it because we can't prove it now. It means this constant is not independent. Yes, sir? Is this? In this case, so up to now, today I introduced the property. The conception to describe the property of a material. We know proportional limiter, elastic limiter, yield limiter, ultimate limiter, fracture stress. Yes, no. We know this kind of conception. This is the chapter 8. This is chapter 8. Then, after I introduce this kind of conception, I will introduce chapter 9. X-loading. For X-loading, we know for X-loading, we know this stress, normal stress, yes or no? Do you know normal stress? How to get the normal stress? Sigma is F N over A. Yes or no? We know if is less than the normal stress, the rod is the tensor rod, X-loading rod is safety. Last lecture, I introduced an example how to get the deformation, the elongation of a rod, of a X-loading rod. Do you have? Can you remember it? Huh? The picture. Yeah, last class. So in this part, we will introduce how to find the deformation of an X-loading member. Actually, it's very easy. Last lecture, some of you can find it. Deformation. We know if a member is safety, it can't break. So deformation must be less than code. Must be less than code. Yes, we must be less than the limitation. So we have to know how to find the deformation. We know from Hawkins law, sigma equal E epsilon. Yes or no? Is the definition of a strain. From the two formula, we can get it. It's the elongation of axial loading member. We can get it. It's the P is normal force. L is the length of the member. A is area. It's a modulus of elasticity of the material. It's the property of the material. We get E from experiment. So it's easy. Easy formula. But sometimes when the rod is not uniform in different part, the normal force are different. How to find the elongation, the deformation of the rod? You divided it into 3 parts. Summation, the deformation of every part. We can get the deformation of the whole rod. But sometimes is positive, sometimes is negative. We know this part is elongation. Yes, no? So it's positive. This part is elongation because it is in tension. Maybe this part is in compression. If the force is more than the summation of the two forces, this part will be in compression. The deformation will be negative. It's the same convention. It means when the rod is in tension, the deformation is positive. Is in positive. Otherwise, is negative. Compression and contraction are negative. Here is an experiment. Look at the experiment. How to find the uniform steel bar in the figure has a diameter of 50 millimeter and is subjected to the loading, so determine the displacement at D, and the displacement point B relative to C. How to find it? Hey, it's okay. You can look at it. This answer is very good. Oh. Okay, at first we have to find the normal force. How to find the normal force? Our normal force is internal force. We use the section of method. The method of section. That's all. At first you see the so wait. At first
yes.
at first the rod is the rod is 70, it's 40, it's 80. Yes or no? At first make a cut at the orbital section in this part. So make a cut. Take the red part to analysis. Consider the red part. The load is 70. The internal force, the normal force, we assume it in tension We'll rule it intention because intention is positive, yes, sir? We'll rule its intention Fn plus 70 is 0. We'll find Fn is minus 7. That's right. We'll find it is minus 7. Defend is 70. But assuming it in the PPT is assumed in compression. One is positive, it means this part is in compression. And solve it, and always so assume the deformation is in tension. So it means it's minus 70. It means it's in compression, is not in tension. My assumption is wrong. Yes or no? Just then, and this part, in this part, we make a cut. We make a cut. The figure is here. We can get a equilibrium equation. It's when I solve it, I will use this method. Is 70. It's 40. It's I always assume it's intention. I always assume it's intention. And we'll find it's how much? It's minus 30. Because it's 70. Yes or no? So it's minus 30. It means for the section of BC, it's in compression. Then, by the same way, we can get the normal force in AB. Yes or no? We can get 50. Then, when you want to find the deformation of the whole rod, make a sum. Yes, make a sum. Make a sum. This is the normal force diagram. It means in this part is this part is what? Is CD. It means in the part CD, for the part CD, the normal force is negative. CD is in compression. BC is in compression. AB is in tension. Because it's positive, it's negative. So it's CD negative compression, BC negative compression, AB positive tension. Make a summation of the three parts. We can get the whole deformation of the rod. It means, the whole rod is shortened. The shorten is minus 89.1. Understand? It's easier. Understand? You see, the displacement of point B relative to C is just the deformation of BC. Understand? So we will let's do excesses, in-class excesses. Also, we know how to find the deformation of extra loading member. It means for this, for a member, for extra loading member, we finish it. We finish it. How to close the PPT? I forget it. Close it. And of the rod. Can you? Try it. It's not clear. Sally, can you solve it? 所以呢，哎呦，所谓的maybe can we 100 kilonewton. Kilonewton. 所以 how to get 70? No, you're wrong. No, you're wrong. It's wrong. It's 70. It's wrong. How to get it? Make a cut. No, you have to at first you have to make a cut. That's a use the free but then free how much? It's 120. So it will be minus 20. It's minus 20. It's 70. Yes. That's that really. At first, we have to know how to find the normal first. How to find the normal first? The method is the method of section. Method of section. For CD, make a cut. Make a cut. Make a cut. Take the red part to consider the red part. It's 100 kilonewton. Assume its intention. Yes or no? We find it's 100 kilonewton. It means CD, part CD is intention. Then for species, make a cut. Is 100 kilonewton. There is another kilonewton. Kilonewton is more. Kilonewton. Kilonewton is convenient. It's a kilonewton. Fn. We will find it how much? $150 because its balance is 50 kilonewton. Then consider AB, make a cut. Put it here. That's how much? Fn we will find is minus 20. Minus 20. It means this part is in compression. So the deformation of the whole rod is theta. It's BC is minus 20. Change is in SI. is a unit. Oh, the original length, I didn't get the original length. Suppose it's 5 meter, is 8 meter, 10 meter, is F, L, E, A, plus E here. A, how to get A? A 是 pi half 200 square is then plus is 50 kilometer hence 8 E A they are same it's times 100 is 10 meter EA. Negative, positive, then make a summation. Is the answer. Fifth. Understand? Here is an example. Then I use another example. You don't understand? Understand? It's okay lah. Didn't answer. Hey, you're very good. Sigma. I don't ask you find the sigma. Just find the deformation. You find the sigma. It's okay. Yeah. Yeah. You have to finish. You have to data. The data, not the sigma. Sigma is. Okay. It's okay. Finish. Okay. Next time. Okay. Take a photo. Here, this problem is your homework. You don't want the homework? This problem homework. Yeah, you just if you want more, you can get it here. Here. Okay. Okay, it's okay. Problem 2. Homework. Okay, that's all for today. Did you get something? Oh. You have to remember what is the proportional limit, what is elastic limit, what is yield limit, what is ultimate limit. What is what? KP is a unit. Is a unit. English unit. English unit. Yeah. Is first. Often, yes. What? Close it. No. This one. Is close.